that will help clarify things. So give me a moment. I'm going to pull up the slideshow and we will begin. Okay. Yeah, AI. Yeah. Yeah, AI. Yeah, AI is a pretty common thing that you'll hear a lot. Yeah. So artificial intelligence. I mean, how many of you guys have heard the term artificial intelligence before? Pretty much all of you have heard it before. Have you heard AI, artificial intelligence? Have you heard of it before?
2001, The Space Odyssey.
Yeah. Perfect. Yeah. Okay. Great. Cool. So there are examples of it in fiction. There's plenty of examples of it in fiction, from 2001: A Space Odyssey to Star Trek. You have that. What's his name? Data. There's that one character in Star Trek who's just a robot, basically. And he has like he does have feelings, but he doesn't have feelings, and it's a whole like complicated thing. But artificial intelligence is a kind of nascent field. It's new, but not really. And there are a lot of exciting innovations and kind of maybe a little bit scary, some frightening. And we're going to be talking about that today. So first, I'm going to read you the Wikipedia definition of artificial intelligence. So according to Wikipedia, artificial intelligence is intelligence demonstrated by machines as opposed to the natural intelligence displayed by animals, including humans. So that is, we have a machine, something mechanical, displaying the same kind of intelligence as a living, breathing thing. Now, different organisms display different levels of intelligence, right? At the top of the, I guess you could say, like intelligence hierarchy on Earth, you have orangutans, chimpanzees, dolphins, pigs, humans. These are very, very smart animals, right? Gorillas, they're animals that can learn things and act accordingly. And then at the bottom, you have like single-celled organisms, like a bacteria. Like there's not really anything intelligent about a bacteria swimming around in a bloodstream somewhere. It's just a bacteria.
So it talks to mammals or
Mammals?
I mean, it talks to you say bacteria, they're not considered as intelligent.
Well, I mean, there's like varying degrees of intelligence. Like I'm like a.
It depends on its biological makeup.
Yeah, right, exactly. And like they're intelligent in different ways. Like a spider can't read poetry, but
it knows where to go.
But they know where to go. They know how to make really elaborate webs, like
Birds
spiders.
communicate with each other.
And clearly spiders are very smart in their own way, in the sense that like they creatively build webs in places that bugs will go. Or there's like different spiders will make different types of webs. Like there's like orb.
That's
Yeah.
genetic.
Yeah, right. And then you could like ask, is that genetic? Is that creative? It's both, really. Yeah. But there's intelligence, right? Yeah. I don't know if it's a brain. I don't know if spiders have brains. I actually don't know that. But like, there's something in a spider or a chimpanzee or us. In our case, it's a brain. Yeah. It's not always a brain, I don't think. No, like.
It could be an automatic nervous system reaction.
Yeah, it could just be like a nervous system thing. Like if you get poked, run away, right? Like that's,
Reflex neurons.
Yeah. And then you have like something as dumb as a jellyfish. And I don't mean that in like an insulting way, but
They'll stay with whatever they want.
that's very true. But like jellyfish, jellyfish have an extremely slow metabolism, so they can live really, really, really long times. But they also, all they do is float. Jellyfish are jellyfish. They're kind of unintelligent. Like they're not like creatively, they're just kind of dangling out their tentacles and hoping something comes up. So there's different degrees of intelligence across the animal kingdom. Now, my next question, or my question for you guys then is, what is it that makes humans intelligent? It's a two-word phrase starting with P and R. What is it that makes humans intelligent? Something we're very good at. Does anybody know? And I included a hint too in the picture. So look at the picture. We have square, circle, triangle, square, circle. What's the next thing? It's going to be a triangle. How do you know that?
It's learned.
It's learned, right?
Logic.
It's logic. In other words, it's pattern recognition. That's the phrase I'm looking for. It's pattern recognition. We humans are very good at pattern recognition, and so are other animals actually. Chimps, orangutans and other great apes are very good at recognizing patterns. In fact, so are certain birds. Like for example, if you walk through a park and there are a bunch of crows in a tree and you throw a rock at the crows, and then you come back to that park 5 years later, those crows will remember who you are. So if you walk through a park and there's a bunch of crows and you piss them off by throwing a rock at them, they will remember who you are. So the next time you walk through that park, they'll either, yes, they'll probably recognize you. Yeah, it's pretty funny. What's that?
You said a bird, right?
Yeah, like a crow. Like a
Crow.
yeah, a crow, like or like ravens, or there's pattern recognition, which is to say, organisms can learn over time through experience. If this happens, then this will happen. It's like a basic fact of life. So if humans realize if you hold your hand over a flame, then you will get burned and it will hurt. So then we learn not to touch fire. Or if you don't eat, well, that's different because we need to eat. And that's kind of like our body knows that.
I will hit.
If we, well, we don't need to get into that, but I mean, yeah, if you call someone a bad word, then they get angry. If you insult someone, they get angry. It's just like pattern recognition. We learn these things over time. A chimp or orangutans will learn how to crack open coconuts. So their mother will teach them, if you take a coconut and you smash it against like a rock like this, you'll split open the coconut. So then later on in life, the orangutan will find a coconut and it will be able to do it all on its own because it learned the pattern of cracking open the coconut and getting what it wanted. So really, this is kind of like one of the most important things of intelligence. It's pattern recognition. It's the ability to remember things that happened and the results that came afterwards. And then if you know that, you can act accordingly. So if we know that putting your hand over an open fire, if we know that hurts you, then we learn not to do that ever. We're just not gonna, and then we know, and then that branches off into other things. If we're working with ovens or stoves or whatever, we know to keep our fingers away from hot implements because it will hurt. That's just something we learn. Another one, nature is constantly playing with pattern recognition, specifically color coding. Things, in nature, things that are dangerous are often very bright. For example, there are certain poison dart frogs in the Amazon rainforest. There's frogs that are colored very brightly. They look like neon street signs. Like they're these beautiful, like bright red frogs with like leopards, black spots. But if you touch them, they're highly, highly, highly poisonous. In fact, tribesmen in the Amazon will take their arrows and they will felt the tips of the arrow with the poison of the dart frog, so that when they fire, it's not just wounding, but it's also poison.
It is a form of defense.
It's a defense mechanism, right? Or take a look at bees or wasps. They're yellow and black. They're and that's to show danger, right? And then we as humans will see a bee, even as a little kid, we'll see like a yellow and black striped thing, and something in our brain says danger. And that's like an evolutionary thing. Like over time, we just learned bright color means we should be paying attention to it. That's why street signs are really bright. dangerous things in nature tend to be kind of bright. It's kind of like it's a warning that we learned through pattern recognition. Now, if we understand that this is one of, if not the most important things to intelligence, like this is one of the most important things for being an intelligent creature, how can a machine replicate that? You program it, but it's a little more complicated than that.
Can you teach a machine self-consciousness?
Beautiful comment. So you're on the right track. So here's the problem with trying to teach machines how to do this. If you want to teach a machine pattern recognition, it needs to see a pattern a few times, right? So let's say we're making a very simple artificial intelligence agent. We're making a computer, and all it does is, if it hears you clap your hands in the room, it will turn off the lights. That's all. So what it needs to hear is it needs to hear what clapping sounds like. And it needs to hear that a few times. Because if you only ever clap your hands in a certain way, then if somebody else claps their hands, then it might not understand. So let's say I always clap my hands like this, so kind of loud, but maybe someone else claps them like this, like, I don't know why they would do that, but they clap their hands like this. This sounds different than this. Exactly. So if the machine only learns what to do when I do this, if somebody else goes like this, it won't know what to do. Another example is, let's say we want a machine where every time it sees a cat, I don't know, it spins a little toy around. Who cares? But what's important is that it can tell that there's a cat. So think of it this way. If we teach this machine what a cat is by only ever showing it Persians, you know, like the white fluffy cats, right? If we only ever show it Persians and it sees a tabby cat, it's not going to know it's a cat. Think about it. If you have a baby, if you have like a human child and you teach them a cat is a white fluffy quadruped cat, right? That's what a cat is. If that kid sees an orange cat, it won't know that that's a cat, because they won't know it's a cat because they think cats are only ever white and fluffy. So it's a little tricky.
Really?
Well, yeah, I know it's hard to believe, and we're smart enough that
The kid, like a kid or a little kid. right?
yeah,
The baby, you say.
like a baby,
The
sure.
kid takes touch, the cat, you say.
Yeah, so I mean, a human kid is probably smart enough to know if the cat is a different color, it's still a cat. But you have to think of it from the perspective of a machine. Machines are very absolute, you know, like they like rules. So if you teach the machine that the rule of what a cat is that it's white and has long hair, and then all the other attributes of a cat. So, you know, the pointy ears, the tail. Then if the machine that has created this rule book sees a cat that's orange or black, then it won't know that it's a cat. It'll think it's something else. So it's important then that we allow it to be versatile. We can't just teach it to always look for white cats. We have to teach it to look for brown cats, gray cats, black cats, orange cats. And another issue here is that we can't write this book of rules manually. We can't sit and write down a set of instructions for the machine to follow, because it would be too long. We would have to give it a rule book of what is or is not a cat that fits every possible cat. And that's really, really, really hard. Think about it. If you wanted a set of rules to be able to say that something is a cat or not, and you wanted to take into account every possible cat, your rule book would be thousands of pages long, because you would need to say, okay, it has pointy ears and a tail and 4 legs, and a nose and whiskers, except not every cat has that. Maybe some cat got in a fight and it loses an ear. Maybe it's a lynx cat. Lynx cats don't have long tails. Maybe it has only 3 legs. Maybe it's a different color. So then you have to be like, okay, well, most of the time it has these attributes, and it gets too complicated. So artificial intelligence is a little bit different from normal programming, because normal programming, like when you write a normal thing, maybe it helps you do your taxes, maybe it moves a machine forward, whatever. Normal programming, you have one set of rules and it always follows them. But artificial intelligence has to have a diverse set of rules that changes over time. Hello, are you here for the computer science like tech course? Yeah, cool. We're talking about artificial intelligence. Cool. So it has to have a diverse set of rules. It has to be able to adapt to new situations. Oh, my close the door here. So there are different ways of doing that. There are different ways of allowing a machine to think and learn over time. And we're going to talk a little bit about that. Now, artificial intelligence relies on pattern recognition. So that's a fundamental truth. When it comes down to it, artificial intelligence needs to see something a few times, or 1,000 times, or even 1,000,000 times to learn what that thing is. And it needs to see a whole bunch of diverse examples too. So for example, and here I have a few examples of artificial intelligence on the slide. So we have an Amazon Alexa. So this, right, it's an Amazon machine. You can talk to it and it will respond. It will help you do your things. The main thing that drives it forward is human speech recognition. So it's intelligent enough to hear us talk to it and understand what we're saying and then give us a response in return. So if we say, hey, what's the weather like today? Then it's able to listen to us say that. It's able to take the little clip of us saying, hey, what's the weather today? And it can break it up into, hey, what is the weather today? It can figure out what the words were and understand what those words mean. Yeah.
I was told that there's a way that you can talk into the computer and it will print out what you say.
Yeah. Same thing. So there it's, so for example, if you're writing an essay,
Yes.
and what's your name?
Roy.
Roy? Okay, so you're writing an essay, right? And you're using something like that. So at the top of the essay, you say, my paper by Roy, right? So let's say you hit the button on the machine, you say, my paper by Roy. So then the computer will listen to you say that, and then it will figure out the words that you said, and then it will type them out.
Is there a particular app that will allow this to happen?
There's like, it depends on what program you're using, but there are a few examples of that. Like if you're using an iPhone, Yeah. yeah, like I mean, there's a button here, like if I type, there's a little microphone button here. And if I hit the microphone button and talk, then it knows what I'm saying. So,
It goes to voicemail at the same thing.
well, that's one thing. Yeah.
And
So-
where is that?
Do you have an iPhone?
Yes.
Here. Let's see. So if you're typing, right? So you're typing, like here, you hit this microphone button to the left of the space bar.
Oh, this over here.
Yes, so here, get the little microphone,
Right.
and then you can talk into the phone.
Right.
And I mean, here the connection might not be the best. Yeah. So that's one example, and that's actually a great spin-off of this. There's also artificial intelligence that can help in the medical field. So for example, you have, this is an artificial intelligence agent that helps diagnose pneumonia. Now, pneumonia, if you guys don't know, is just when water builds up in the lungs or mucus, right? It's actually a side effect of COVID, right? Or it can be. if COVID gets bad enough. But here, these are some x-rays of different patients. So yeah, I don't think these are all the same patient, but here, this is just a normal person without pneumonia, right? This is somebody who clearly has some not normal buildup. So we can see here, like in the lungs, it's pretty clear. There's not a whole lot of moisture, right? Here, there seems to be something coagulating over here. And over here, there's clearly pneumonia, right? So we can actually teach computers to learn this kind of pattern. When I look at these images, I'm able to tell which one does and does not have pneumonia because I can see there's a cloud of gas here. And you can actually teach computers to do the same thing. Yeah.
I don't see it.
If you're typing, it's to the left of the space bar at the bottom of the keyboard. If you have the keyboard open, it's to yeah. So if you're it's just whenever you're typing something. So if you're typing like a message or you're in
You have to go into a function.
yeah, well, yeah, you have to be in order to have it work, you have to already have the keyboard open. Yeah. If you're like writing an email, yeah, then basically you're allowed to do it when the keyboard is open. So the keyboard will appear at the bottom of the screen. And then once the keyboard is there, the microphone button is to the left of the space bar, which is at the bottom of the keyboard. Another example of artificial intelligence is it can make art. Kind of. I mean, this is a little creepy, I think, but do you see this picture on the left here? This is an artificial intelligence making a painting. So again, I think the painting's a little creepy, but this is basically an artificially intelligent computer looked at a whole bunch of paintings and it came to understand what a painting looks like. So then a human asks the computer to make a painting. And so based on all the paintings it's seen, it generates something like this.
What were the information supplied to the computer to make?
Yeah.
What was it told to do?
Could be like, it was given, yeah. Okay, so great question. So it was probably given like a museum catalog, right? And then it was just told, make a painting. That's it. But you can be more specific. You could say, make a painting of a woman or make a painting of a bird. And now you'll notice too, this is like I don't know what you call this, impressionist? Like, I don't know what this would be called, but it's like a watercolor paint, not a watercolor, but it's a painting of it's like a portrait of a man, right? If you instead trained the machine using like contemporary abstract art and then asked it to make a painting, it would look a lot different because that machine learned what art was from modern, like, abstract art. So then you ask that machine, make a painting, and it'll put like a blue square and a yellow line and something like that. So yeah, you can also detect species of birds. You can use it in science. So here we have two pictures of American goldfinch birds. Well, actually, I can't zoom in, but here you feed in this picture of two birds and the computer is able to tell that these are both goldfinches. The bird on the left here is a male and the bird on the right is a female. And it's able to tell accurately that both of these are goldfinches. It also, for each of these, it gives a confidence score. So 0.758. Yeah. And finally, we talked a bit about this in class. It can also do self-driving cars. And now these aren't the only things AI can do, but these are a few examples. And self-driving cars are very tricky, both in terms of how you make them, how you code them, and then once they exist, the moral ambiguity of them. Do you have a question, Roy? Oh, okay, yeah. Cool. So they rely on big data. right? So if machines are intelligent based on pattern recognition, if they're able to learn things by seeing examples, they need to see examples. Yeah.
You have to type it.
Here, let's see. See if I do iPhone keyboard. Yeah, so take a look at the screen real quick. It's gonna be, the way you do it is, you see, this is what the keyboard looks like, right? So it's this button right here. You see this button here? It's that button. So if you hit that button, yeah. And then it will show,
Where do I talk?
you just talk at your phone. And then it will show like a line. It shows like a line, and yeah, and then so if it's showing that, you just talk.
Say something.
Oh, okay. Where, okay. Script is being written.
Also, it might be slow because we're here, but yeah. So in order for these things to work, they need to see a lot of examples, right? And they rely on big data then. So if you train an artificially intelligent machine to be able to tell different species of birds,
What does the text appear? Both.
it will appear wherever you're typing.
I think it was in what you were saying.
Yeah, so if you're typing an email, it will appear in the email.
Putting it in notes.
But it was a little bit of issue because, well, it took a line.
Here. Let me see.
Here.
Yeah. No, that's right.
Okay, and then I'll just press stop.
Yeah. You use push button.
We're doing this.
You mean course?
Yeah.
I don't know, all the code.
Oh, that.
Sorry.
I think he's very nice.
Okay.
How did you take rid of the page?
Then you just hit done, and then you're good. But let's focus on the lesson for now. We can handle that later. So, in order for these kinds of things to work, they need to be exposed to different experiences, just like us. So, if we want to learn how best to swim, then we need to practice by swimming a whole bunch, right? If we want to learn how to speak a language, we need to speak the language a whole bunch of times, and we need to hear other people speaking the language, right? If a machine wants to learn what certain birds look like, it needs to be given thousands of pictures of birds. Or if a machine wants to learn how to understand human speech, then it needs to hear humans talk. So a lot of different artificially intelligent agents that are popular today rely on big data. Now, this is where a lot of these things get a little bit morally ambiguous. This is one place. So big data is taken sometimes by surveillance. So in the case of Amazon Alexa, that little home assistant thing, one reason that it's so powerful and that it's able to understand us so well is because it's listening like all the time. And so it has a lot of examples of what people sound like. So if it's listening all the time, and that means it's collecting a lot of examples of what people sound like, which is good for it because it learns quickly, but it's also a little bit creepy, right? So another example is advertising. So artificial intelligence is used in advertising because a computer will guess how appropriate an ad is to show you. So let's say, for example, I have 3 dogs, okay? I don't, but let's just say hypothetically, I had 3 dogs. And there's a company that sells dog food, okay? So there are millions of people in New York City that this company could advertise to. But like, Diane, do you own a dog? No. Okay, so the dog food company would rather advertise to me than it would to Diane. Because if the dog food company shows an ad to Diane, she doesn't own a dog. So she's not likely to engage with the ad. So they need to understand that I am a dog owner. Now, in order to do that, they look at my activity online. They see if I'm looking up things like how to give my dog a bath, or where can I order a dog collar, stuff that somebody who owns a dog would look up, right? If they can tell from evidence of my activity that I own dogs, I will start seeing advertisements for dog food. But somebody who never looks up anything related to dogs probably won't see an ad for dog food. And the thing is, it's not like there is a human, that's watching me and figuring out that I like dogs. Because if that was the case, you would need one human for every human. You would need for example, for all however many million people in New York, you would need one person watching their activity and figuring out, oh, this person likes dogs. That's just not efficient or financially feasible. So instead, we have a computer look at the activity, and one computer can look at the activity of millions of people and figure out these things on its own. So this is one part of AI that's kind of shady. And it's also why companies like Google, Twitter, Facebook, Amazon are often criticized, because they do a lot of monitoring. They're trying to collect as much information as possible to understand who you are and what advertisements to show you. For example, if you're on Amazon and you buy, let's continue with the dog thing, okay? So if I go to Amazon and I buy a dog collar and I buy a dog leash, and then I go back to Amazon 3 days later, Amazon is going to advertise dog food, dog muzzle, dog jacket, dog stuff.
Not only that, they really personalize it. They show you, last time you looked up this.
Yeah.
Your history.
Yeah, they'll show you their history. And then when you buy products later on, it will say stuff like, users similar to you also bought. Exactly. So it's able to tell, not only is it able to tell what you like, it's able to tell who else in Amazon's, I don't want to say community, but who else, who else in their database is similar to you. Yeah. And is that,
You have a pixel. By Google, and you take a picture and you say, pick a better shot. Excuse me, I mean, it's my problem. What is wrong with myself? Or that now when I want to see what I used to have albums, now I have a first row that for me 1 year ago, 2 years ago, last week.
Yeah, it does the same. Yeah.
Second, the telephone without my permission has made videos out of my different pictures online.
Yeah.
It creates things like this.
Yeah.
I mean, it seems that every time they update, there's something that can they make animations with your
It does the same thing on my phone. It'll make like a.
This is invisible privacy.
Yeah.
It's I mean, this didn't exist before I had this phone.
Yeah, and actually,
By the way, I would like to know if I can opt out of.
I don't know if you can opt out of
all
that.
those intrusions, because it's also a waste of time. Instead of having pictures I can access right away, I have to not to move out or register.
What function is it that's doing that?
It's like
Because pictures is made by Google, and Google
Picture,
originally.
what picture?
it'll take pictures. It'll take pictures that you took a year ago.
Well,
Like-
how do I know it's on the picture? Picture.
Well, no. So the truth is, it's not like they're. Okay, so I went to Coney Island like a year and a half ago, right? So then a year after I went to Coney Island, my phone told me, hey, a year ago, You went to Coney Island, and here's a bunch of pictures of the Ferris wheel and the beach and all that stuff. I also made you a little video, and yeah. Now,
But I mean, I made more function.
it just does that. It's like a feature of some of the photo stuff.
In photo mode,
Well, like
because I don't, I have.
on the iPhone, right? I can go to the Photos app,
Right,
and it shows me all my photos.
right.
I mean, here, I mean,
I don't have anything like that happening. So
That's fine,
I don't use it.
here, I mean, look. If I go to my Photos app, it shows me, here, do you want to look at some portraits on your phone? So we have, for example, here's my brother looking,
They should already.
this is my little brother. Yeah, but
3 years ago, a year ago,
I don't take photos of anything.
don't worry about it. Do you have a question?
I don't
Yes,
use the phone.
I used to work in advertising and if I wanted to reach a target audience, like you said, dog owners.
Yeah.
Do I send that message to Amazon and then Amazon picks out the people who are relevant?
Great, that's excellent question. So it depends on what platform we're talking about. On Amazon, it's more like if you're a business owner and your business is making dog collars and you put your dog collars on Amazon, Amazon will take care of advertising. So they'll kind of help out your business by figuring out who needs the dog collars and then putting your dog collars on their pages. But what you're mentioning is more like Facebook. So one reason Facebook is so successful isn't just because it's like a social media platform. It's also because Facebook by nature has a lot of information about it, right? So Facebook knows who your relatives are, your interests. So with Facebook, you can do something like, I want to advertise, and I think I brought this up like on Monday. I want to advertise to all 50-year-old men or 50-something-year-old men in West Virginia with a wife and 2 daughters and 2 dogs that own an Apple phone. Like, you see how specific this is? And you can tell Facebook something like that, and Facebook will go, sure, I got you. I don't know why you want to advertise to this really specific constituency, but Facebook has so much information that they can just generate a list of all those people that applies to. So their Facebook is not, it's not really Amazon. It's more like Facebook's, one of their biggest services is you can advertise your business on Facebook and you can advertise it to a very specific demographic. My mother, for example, runs a jewelry business, and she's used Facebook in the past to advertise. She tells me it wasn't that successful, actually, but she runs a jewelry business out in Chicago. And so she was able to advertise, like, she was able to tell Facebook, I want you to advertise to, I don't know, like 20 to 70-year-old women.
Do you
My
pay?
business.
Do you-
Yes, you have to pay. Yeah.
You have to pay this to do that?
Yes, and it can be pretty pricey, depending on how specific you are. So if you do like the West Virginia thing that I just mentioned, where you're advertising to a really specific sector, it gets pretty pricey. It can be like $100 something. It can be a few $100s for just a few interactions because it's so specific. Facebook, that's kind of that's really what makes them a lot of money, is that their advertising that they supply businesses is so powerful because they're like they're just a bag of information and they use that to their advantage. So yeah.
Well, for example, I'm a musician. I want to advertise a CD.
You can use Facebook. I mean,
I can use Facebook.
yeah, look, you should Google Facebook advertising and then just go down that rabbit hole. Yeah. But they rely on big data. So another thing is that AI can be morally ambiguous. So this is the slide from before. Amazon Alexa and self-driving cars and a whole bunch of other applications of AI can be kind of sketchy, right? So sketchy, like the kind of sketchy, which means like, strange or kind of creepy or unsettling, So The Alexa, a lot of people will not buy one because it monitors so much information. The self-driving cars, I mean, we've had an entire segment here on like morals in AI, and we talked a lot about self-driving cars. So if you were there for that, you'll know that it can get like insane with self-driving cars. But self-driving cars lead to their own list of controversies and mistakes and issues, right? And these aren't the only ones. There's Amazon tried using artificial intelligence to screen applicants for their software engineering roles. So if you applied to Amazon to help them write software, there was a computer that would look at your resume before a human. And if it wasn't deemed worthy, it would just be thrown out. So it was supposed to help Amazon recruiters not have to look at as many resumes. But there was a controversy where the machine Amazon was using to do that was trained using very biased data. So remember, these things learn off of patterns. So like, for example, this machine that makes art drew this painting because it saw, I don't know, like 1800s portraits of people, right? It saw paintings like that. If it was trained using medieval manuscripts and then it was told make a painting, it would draw a medieval manuscript with like all the weird like 2D perspectives, right? So think of it that way. This machine was told by Amazon, find me applicants that would be successful here. That would be successful at Amazon. Find me people who would be good programmers at Amazon. But think about it. Most programmers on Amazon are white dudes. So if you put on your resume that you were a woman, or that you were a minority, or that you were disabled, it would take points away from how good your resume was. This was pretty bad. For example, if you put on your resume like captain of the Harvard the Harvard women's basketball team, which is insane, by the way. Like if you're applying somewhere and you say, oh, I was the captain of the women's basketball team at Harvard, that's really cool, right? But it would take a point off because you said the word woman. And this is an example of a bad artificial intelligence, right? There's also artificial intelligence in warfare. I'm gonna guess the Pentagon in the United States has drones that are piloted using nothing but AI. So like they don't rely on human pilots. They fly themselves and look for targets, which could, yeah.
Is there a format for putting down your resume, or can you just tell them to Google your name and you find out?
If you apply, I've actually applied to Amazon before. If for Amazon, you give them a copy of your resume. So you don't like mail it to them, but you have to download your resume and then submit that file to them. So yeah, but with there are like machine powered drones, like, you know, literal like killer death robots. Those don't really exist out in the field today, but you can have artificially intelligent drones. What else? Another bad example.
How spread is the use of drones?
Well,
have you seen them used?
well,
What about the play scenes?
yeah, I've never seen a combat drone, obviously, but drones are pretty widely used. But those are all like piloted by people. So like drones, drones are very, very big in warfare today. There's drones in Ukraine right now. There's plenty of drones. There's drones in the Middle East. A lot of these will be called.
Yeah, use to carry weapons.
Yeah. So how a drone works nowadays is called it's called a UAV, which is a unmanned aerial vehicle or some unmanned aerial vehicle. It's basically a big plane that is so high up in the sky you can't even see it. Like it's elevated so high that we can't even see it with the naked eye. And it has an extremely high-powered camera. And you can then use the drone to fire rockets at like a certain location. So for example, during the Trump presidency, the leader of ISIS was named like al-Baghdadi or something like that. So the leader of ISIS was actually killed in a drone strike. So I guess Trump authorized it or something, but some American sitting in a chair in like Arlington, Virginia, was at a computer, and he was using the controls of the computer to move this plane around out in like Iraq or Syria, and fired warheads at that guy and killed him. It gets really bad because sometimes they miss. Sometimes they target the wrong guy. Sometimes there's a dilemma called like the two guys in a car. If your target's sitting in a car with an innocent civilian, do you shoot the car? And there's a lot of the US, like America's track record in the Middle East is obviously pretty terrible, but like there are a lot of examples of us just like hitting schools and like it's really bad. Yemen right now, which is a country south of Saudi Arabia, is unfortunately like it's war torn. There's a lot of strife there, and the US and Saudi Arabia deploy a lot of drones there. So artificial intelligence, hypothetically, artificial intelligence could be put into those machines. So now that same drone that fires rockets at the surface of the earth, instead of it being piloted and moved around by somebody sitting in Virginia, it's just moving on its own. But that could be bad because if the computer fails, it hits somebody else. I don't know.
Can they be detected by the other side?
And that's the other thing. Yeah, all good, don't worry about it.
Wow.
It can be taken over by the other side, and that could be bad. Yeah, for sure. It's crazy, right? It's crazy.
Thank you.
Yeah, good. I'm glad. There's also we're still going. She just has to leave early. We have a few minutes left. She just has to leave early. So if you want to keep learning, then you're welcome to stay. Yeah. There's also enormously helpful and interesting examples of AI. So there's also very helpful and interesting examples of AI, right? So AI doesn't have to be all scary and bad. There's also a lot of really cool applications of it, like for example, helping us with the medical field. Like here, hospitals aren't going to they're not going to rely on artificial intelligence to help diagnose things, but at least the computer can give a second opinion. So a doctor can say, I think this patient has pneumonia. And then you can put your pictures through the computer and the computer might agree with you. Yeah, I think this person has pneumonia. And it has, I mean, you can also make stuff like this. There's even AI that can generate music, and it can generate different types of music. So if you feed in a whole bunch of like jazz from the 20s and 30s, then the AI will try to make its own jazz. You can feed in classical and it'll give you a random classical song, a piano concerto or something like that. You can feed in modern day hip hop. Actually, if we have time, I'll show you an example. But it has some weird like artistic creativity to it. And it can be helpful in science too. So here it can detect different types of birds. It can also be used in astronomy. So when we look at the night sky, it can detect like, oh, I think there's a supernova happening over here. Or I think that there's a black hole over there. So you can use it in astronomy. Yeah.
Is this something that you can do with any computer, or do you have to have a special computer that can create artificial intelligence?
Excellent question. So when it comes down to it, artificial intelligence is actually just a bunch of math. So pretty much any computer can hypothetically do it, but it's going to be way faster on more powerful machines. And it depends what you're using it for. So for example, something like this, right? So the bird thing, like what type of bird is this? I could probably do that on this machine. I could probably train this computer to detect different species of birds. But if we're doing something way more complex, like human speech recognition, like teaching a machine to transcribe things that people are saying out loud, then what usually happens is someone like Google or Amazon will do that on like a massive supercomputer. They'll teach the massive supercomputer how to recognize human speech. And then they'll take what the supercomputer learns, and then they'll put it in the phone or the computer. So it's like that big, massive supercomputer that those companies own figures out how to recognize human speech and like jots it down in a set of instructions. And then we just take that set of instructions and put it in our phone.
But if I'm not mistaken, I don't know if it is with this one, but I had to repeat 3 words before to like.
Yeah, they're not always that good.
To make it recognize your.
Yeah.
One of my stock brokers says your voice is your recognition or is your password. Is it because they have some sort of a way to recognize my voice, proper voices?
It might be. I'm not really sure in that example, but something kind of similar is new iPhones. I have a kind of older iPhone, but new iPhones have a feature where you don't need to type in a password. You don't even need to put your thumb. All you do is you look at the phone and it unlocks itself.
Yeah.
It recognizes your face.
Yeah.
So it'll trace out like the edges of your nose and what your mouth looks like and how your eyes fold and stuff like that. And then it's able to detect.
This was in Mission Impossible.
I know. I know.
The original.
I know. When I heard Apple was doing that, I'm like, that's like something from a spy movie. But no, it's a real thing. Yeah. So that's the thing. They can be kind of morally ambiguous. They can be interesting, or they can be both. Like they can be kind of creepy, but also kind of cool, which is kind of what I would say about the Alexa. It's kind of creepy, but does have its uses. When I'm getting ready in the morning, you know what I do? Exactly. I say, hey, Alexa, what's the weather looking like today? I say that verbatim. Hey, Alexa, what's the weather looking like? And she'll tell me it's like, I don't know, lately it's been really, really nice out. But yeah. Let's see, we have a good like 5 minutes. You know what? I'm not going to try to explain this. It's super cool, but to put this slide into brief words, basically, there are different ways of programming artificial intelligence, but one way that's super interesting is called a neural network, which is modeled after the human brain. So the human brain, when we learn things, we have, our brain is made up of brain cells, right? These are very valuable cells. They are very weird in compared to like a blood cell or a white blood cell. So these guys are built specifically to pass information. So like, what happens when a kid who's been playing violin since they were 3, let's say they're 30 years old and they pick up a violin and they start playing. What that is that there was a highway of neurons in their brain, right? And these neurons all communicate with each other. They communicate on a one-way highway, so they pass information forward. This girl who's been training since she was 3 to play violin, when she picks up the violin when she's 30, she has a set of neurons in her brain that have been doing this for years. So here, actually, we look at the cell here, these guys here, these dendrites, these like branches coming out of the nucleus, those are responsible for taking in information. And then out here, these axons send out information, or it might be the other way around. But what happens over time is, actually it might be the other way around. But in any case, over time, as you learn something better and better, those neurons, the connections will physically open up more. So if you have a pro like trumpet player or a pro basketball player, the neurons in their brain that are responsible for doing those things, the pathways between the neurons are really, really open. So the messages between the cells goes through really fast.
Can in fact duplicate what the brain can do with artificial intelligence techniques?
Perfect, Roy. That is exactly what you do, actually. So what a neural network does, so that's kind of like how the human brain is. You learn things, And the better you get at those things, it's part of that is literally your brain, the connections between those cells is opening to receive information faster. Or sometimes the neuron up here is actually not contributing very well to something happening. So the thing will close. So if the neuron up here is communicating something wrong that wouldn't help me play the violin or play basketball, I will actually close my connection. So it learns over time to open and close and like allow more or less information in.
Theoretically, then, I could find a way to read your mind.
Yeah, I mean, if you had like a perfect map of my entire brain, yes. But that's really, really, really hard to do, it turns out. It's like that's a very interesting point, but we've studied that, and this thing, like the pink thing in here, is really complicated. We have wondered if it would be possible to take a human brain and understand it 100% and then put it into a computer, and it's not theoretically possible because it's not theoretically possible because it's so dense in here that there's just too much to account for. But now Roy actually touched on this. Some artificial intelligence networks do exactly what our brains do. That's why they're called neural networks. It's because they're based on the human brain. So
there is, I've studied a meditation technique that says that when a group of people are meditating using the same technique, they create an energy that is greater than the individual possibly could have created by themselves, and can then impact others. To the effect of creating a healing, medical, for example, they are now finding a way to treat post-traumatic
stress
disorder by way of a meditation technique.
Yeah. I mean, it's cool. Like, it's cool figuring out what our brains can do and how they operate.
Yeah.
And so certain engineers have figured out how to kind of replicate that. So with a computer, you can actually kind of simulate what the brain does. You can take in information and you can feed it through a whole bunch of neurons in a computer. And then the computer will try to do something. Now what happens is each one of these dots here symbolizes a computerized neuron. So each one of these dots is the computer's representation of this, the human brain cell, right? So here's what happens over time. If this neural network is trying to tell what species of bird is occurring, so we take this input layer, we put in a picture of a bird, and then there's a bunch of math that occurs in here, and then at the very end, it gives us, oh, I think this bird is a woodpecker. Now, here's what happens. This thing is going to get better over time, and it will get better over time because it learns to open and close connections to good and bad neurons, respectively. So let's say this neuron right here, like this one on the top left. Let's say we put in a picture of a woodpecker, and this neuron says woodpecker. And then we put in a picture of a finch, and this neuron says finch. This is a neuron that does great. So what we're going to do is we're going to heighten its voice. So that neuron, whatever it's saying, we're going to take more seriously because historically it's done really well. Okay, let's take this neuron over here. So the middle bottom. Let's say, like the green one you see.
You can detect the color, then recognize or take care of the color thoughts.
Oh, well, and that, what it's doing there.
You should grab this color.
Yeah, well.
No, that's not what it is.
Well, no, so when you put in an image, it's just going to read every pixel in the image. So that means if you, like a photograph on a computer is really just a big mosaic of squares, right? So if you look close enough at the picture, it's really just a bunch of squares. It'll read all of those squares, yeah. So let's say this neuron down here, if we feed in a picture of a woodpecker, it says, oh, that's a hawk. Or we feed in a picture of a duck and it says it's a goose. Or we feed in a picture of a, I don't know, how can I not think of another bird? We feed in a picture of a swan and it says it's a eagle. Yeah, whatever. It's always getting it wrong. So this one's clearly not doing that well. So the cells ahead of it are going to kind of ignore it. It'll learn to take the opinion of that neuron and turn it down because it's not really contributing much. And so over time, the network will figure out which cells are doing well and which ones are not. And then it will act accordingly. It will take the cells that do well and it will listen more to those cells. And it will take the cells that don't do well and it will kind of shut them up a little bit using math. So we have stuff like this that can actually learn just like a brain does. So
every cell on the side can create, can grow more, more links.
yeah, no. No, so a neural network is like, it's, when we make one, when a programmer makes one of these, it's like an architecture. You put it and then you let it go and it's gonna be stuck with this architecture unless you stop it and then remake it. So like here, this is an input layer with 3 cells in it. And then there are 3 hidden layers with 4 cells in each. And then there is 1 output layer with 1 cell. So we see 3, 4, 4, 4, 1, right? That's gonna be what its architecture is. If I wanna add another cell in here, so I want 3, 4, 5, 4, 1, I have to stop the machine, add that cell, and then restart. Yeah, so it's stuck with whatever we say.
What is your name?
My name is Augustine.
What is it?
Augustine, like, you know the city in Florida, St. Augustine? Augustine, yeah, like the saint, yeah.
Like the emperor.
Like the emperor, that's even better, yeah, Augustus, yeah. It was nice having you, Roy, yeah. Cool, so that's neural networks, it's just one method. And so, actually, the last thing I want to do is, let's see, AI generated music. This is the last thing I'll show you guys. It's actually kind of cool. So,
Thank you. I can't tell you how invaluable your
yeah, if you want to.
Instruction and explanation and patience has been. This is the most I've ever gotten out of a computer presentation.
Thank you. That's very nice of you. And I.
Are you going to be here again next week?
Every Monday and Wednesday at 1:30.
Monday and Wednesday. Oh, yeah. I look forward to seeing you.
Cool. Yeah, absolutely. 1:30 on Monday and Wednesday. If you want to stick around for another like 3 minutes, here, let me show you. Let's see. I'm trying to find where I can find classical music. Let's take let's see. Explore all samples. So I'm going to show you guys a machine playing classical music. Let's do classical. Let's see Ludwig van Beethoven. So that's a machine trying to imitate Beethoven. Here's one of it trying to imitate Tchaikovsky here. It's kind of quiet. Maybe Mozart. Yeah, let's try Mozart. Now you can hear it's like gibberish. Do you hear it from here? Yeah, the words are just gibberish. It's not saying anything. Let's see, how about, say, Ella Fitzgerald here. So here, it's taking Ella Fitzgerald's voice and then trying to make a new instrumental behind her. And it's kind of working, but this is like a. What, sorry? Say that again?
The text,
Yeah.
the lyric.
Yeah, so these are the actual words, right? This is an actual song from Ella Fitzgerald, and then it takes her singing and tries to put a new set of instruments behind her, which kind of works. Yes, this is like a research project probably. Another example I could do is here. Something called a deep fake. So these are kind of scary. Let's try this out.
I am not Morgan Freeman, and what you see is not real. Well, at least in contemporary terms, it is not. What if I were to tell you that I am not even a human being? Would you believe me? What is your perception of reality? Is it the ability to capture, process, and make sense of the information our senses receive? If you can see, hear, taste, or smell something, does that make it real? Or is it simply the ability to feel? I would like to welcome you to the era of synthetic reality.
Okay, so that looked real, right? That's not him. In fact, that's not even him talking. That's all fake. There's actually, it's really hard to tell, but there are certain ways, it's very slight, but there are certain ways you can detect it. One, if you watch his eyes while he talks, they're very dead. He's not, like, Morgan Freeman's an actor, he's very expressive, but this entire movie, he's looking into the camera like a deer in headlights the whole time. Another thing is AI aren't very good at blinking. They're not good at blinking. If you make a fake, he is blinking, that is impressive. But a lot of the time, if you make a fake video of someone talking, they will never blink. So a lot of people will make fake videos of like Joe Biden or Trump, and then they'll post them online saying, look at what Joe Biden said. And it's him saying something completely unbelievable because it's just made up. But in those videos, they just won't blink because computers don't really understand blinking yet. Here, he's blinking, but, oh, and his voice is made up too.
Do you see?
How do they get the image if it's not really, you know?
Great question. They took a picture of Morgan Freeman.
Yeah.
And then they took a video of someone saying this.
Uh-huh.
So they took a video, like I could sit and redo, they would take a video of me doing the speech that he just gave.
Uh-huh.
So what they do then is this is what they do. The computer will learn how I posed my own face,
Uh-huh.
okay? And then it will figure out how I posed my face, but instead of showing me saying the thing, it will take the poses that I did with my face and instead use a picture of Morgan Freeman doing those same poses. So what I mean by that is, like, if I, in the middle of the speech, if I like look off to the side like this, then Morgan Freeman will look off to the side like that. It looks a little janky right now. If you watch it, you'll see like the side of his head will be blurry, or his eyes won't be reflecting the light correctly.
And what about the mouse? Could someone deaf use lip reading?
Yeah, that's actually great. So
The
there,
movement of the lips are more than the real words.
no, yeah. So the another thing too is his voice here is synthetic. So him speaking here.
If you can see, hear, taste, or smell something,
That's not him speaking. I'm pretty sure.
Doesn't what?
That's not Morgan Freeman speaking. That's,
What he was saying?
yeah. It's probably,
So we close down.
what it probably is it's a computer.
Here,
Yeah, whatever. A computer listened to Morgan Freeman talk and then figured out exactly how he does it and then replicates it. Yeah, and these are getting better, which is a little concerning, but yeah.
then you have other thing?
No, I think that's gonna be it for today.
I did the same coming to you first. Have you seen